Hello, hello. I would like to now talk about the introduction and case studies of Vald, AN Dense Vector Search Engine. This is today's agenda. We hope that through the introduction of demonstration of Vald in this session, I hope you learn about the features and application of vector search. I will begin this presentation. My name is Kato. I'm a product owner in the technology field at the Yahoo Japan's R&D organization called TechLab. Now, the quick overview of vector search technology. The more and more data application, data usage is on the rise. Vector search technology is a method of searching for similar vectors from index vectors by expressing the similarity of unstructured data, such as images, sounds, and a vector space, and calculating the distance between vectors. In the case of high-dimension vectors, KNN increase the number of calculations, so it's more common to use ANN. Data formats, as long as they can be converted to a vector, it can be handled. Various formats are acceptable: text, images, video, audio, and binary. Range of application includes similarity search, of course, and the recommendation and data analysis as well. Some of the use cases includes Google image search, YouTube, and Spotify's recommendation. That also uses vector search technology. Three components are required to achieve vector search: embedding model, index stores, and search algorithm. The embedding is responsible for converting object data to vectors in machine learning models such as BERT. Index score is a layer that stores a vector index to be searched and is used on memory, storage, and database, various variations. And algorithm is the core logic of vector search. Examples include NGT, scan, faces. Now, I would like to give you the overview of the data flow of vector search using an example of similar image search. Now, the index phase. Here we use a similar image search as an example. Images stored in index stores are converted into the vector using an arbitrary embedding. Next, the search phase. In this phase, similar to indexing phase, query objects are converted into vectors using the embedding model, using the vector as a search query. Then, ANN's algorithms gets executed, and similar search results gets returned. Finally, by converting the vectors into images, similar images can be obtained. Nowadays, vector search trends are as follows. These are some of the popular ones now: Google, Yahoo Japan's NGT, Anois, Meta, the Faces. And for vector search engines, Vald, Melbus, Quadrant, Well V8 are some of the standard ones. Cloud services ones include the Vertex AI matching engine and Pinecone. In this session, we will be talking about Vald. Vald is a distributed, fast, approximate, and nearest neighbor dense vector search engine for OSS running on Kubernetes. It is designed open source and enables a real-time vector search for billion-scale vector data and flexible customizability. And using gRPC, it's possible to connect from many different languages. And Vald is developed using Go language and uses Docker and Kubernetes technology. NGT is used as a core library. And key features include, shown on the screen, axonic indexing all the way to vector data replications. Now on to architecture. Vald uses a microservice architecture and highly in great compatibility with the Kubernetes. Each component can be customized according to use cases. First, about LB gateway. This is the endpoint for the Vald cluster, very important. All the indexes go through these gateways. And it has a resource-based load balancers. Data can be inserted in more even fashion. And reranking for the search is something that gets returned as well, reflecting the returned response from the agent. Next, about Discoverer. Kubernetes API servers are linked, and node and pods resources are collected, and those captures the information is communicated to Vald through Vald LB gateways and Vald Index Manager. Next, on to Vald Index Manager. It manages the index state, allowing index data to be updated without any service interruptions. Lastly, the core of Vald agent, which is the heart of the Vald cluster. Actual ANN algorithm NGT is executed here. Now, I'd like to give some unique function of Vald, distributed index replication. The main purpose are three. One is to prevent loss of index due to failures, and indexing multiple indexes as evenly as possible to smooth out the memory usage of each agent pods and make efficient use of compute resources. And lastly, because we're able to optimize our compute resource usage, we can improve the search speed. This is how this indexing data flows. From vector A to Y can be indexed in. And LB gateways which accepted this indexed data makes an insert as a replica for one of the agent pod. Now I'd like to tell you how the index destination is determined by LB gateways. We'll use the example of agent pod in the Vald cluster running on 3 nodes. The memory usage of the memory usage is different as shown 70, 50, 40. And the memory usage of each node is attained, and that's how this prioritization is based on. Next, the priority is determined based on the low node usage situation. And the reason why node 2, agent 2 is not shown, if the same node distribution is given as a prerequisite when determining the distributed data and making a priority. So 3, 5, 2, 3, 5, 1, 2, 4 is a priority list that Vald determined. And as a result, in case of index replica 3, this time 3 and 5 and 1 are the places where it's inserted. And before deploying this algorithm, you can see that the memory graph was rather messy like this without resource-based load balancing. Now with a resource-based load balancing, you can see that the usage is optimized. And also agents out of memory kill is prevented because of this. Next, on to automatically indexing and backup. On Vald, Index Manager controls the flow. And for Vald cluster, making sure that little by little indexing is made by each agent. Next, on to search architecture.
This is the flow of the vector data search. So in this case, we assumed a query to Vald 2, and LB data there is first you receive a search request, and number two, for all the agents, there are two ANN search was conducted for the two top items for each agent, and there is an assumption that there is n units. So actually, nil and after the data will be returned. In this process 4, from the nil, there will be data search down to 2. So let me cover this aggregation process. So first, assumption is that there are 3 agents, and also because of the impact of network latency, we have not received the result of the agent 3 yet. So in the order of arrival, we utilize the algorithm to receive the sequence in the queue buffer, and by one, the data will be processed upon the order of arrival. But the data suddenly itemed, the ID will be recorded in enqueued ID list, and it will be utilized to process final processing. And with this timing, the number 3 data arrived. So the number 3 data is coming into the queue, and from the top of the queue buffer, the data will be stored in the reserve request. And the result list will have more data. So ultimately, top K3 items in this B data will be recorded as the longest distance. So max distance 0 to 3, 4, 6. In this case, that this distance, longest distance, will be recorded. So as a result, this the data having a longer length of this can be driven out of the search kit, so this data will not be processed anymore. Next is there is arrival of data B. Because the distance is shorter than that of the B, the max distance will be updated, so agent D data will not be processed anymore. So by having this, without processing all the data, you can get top K. So in this algorithm, the network latency and it works very well, the latency, so you can save a lot of time required. So far, I have covered the vector search outline and the trend of the vector search, and having a deep dive of the Vald. Next, use case and actual deployment cases, Yukawa-san will be covering. Yukawa-san, please. From now on, I'd like to cover the Vald use case and the demonstration. This is Yukawa speaking. And since 2020, I've joined the Vald team. And currently, I'm serving as a Vald project manager and covering CRE area too. So next, I'd like to cover use cases and also deployment cases. So in the vector search, the applicable area is wide-ranging. Here, I have taken examples of search, classification, recommendation, and analysis. So I focus in these 4 areas and how to utilize Vald there. So in search, the most typical one you can imagine is a similar image search, but there is the acquisition of object data very similar to the object data you'd like to search. And in the classification for input object data, you categorize that object data, which group it will be belonging. For example, face image recognition could be a possible applicable case in this case. In a recommendation, for the object data to be searched, you would be returning as a result of the search result for the item you recommended. On EC, recommendable products and merchandise and personalized internet advertisement will be the possible applicable areas. So lastly, I'd like to cover analysis. In the analysis area, anomaly detection and detection malware is the applicable areas. For the chronological data and binary data, and a variety of object data might exist. In advance, you get the anomaly state information and also the vector about malware. By having such a vector search, you can analyze input data. So far, I have covered the possible use case of the 4 areas for Vald. And let me cover actual use case from now on. So first is Yahoo Japan Shopping. In Yahoo Japan Shopping, on smartphone app, there is image of search based on the similarity search linked with the specific category. This is an example of the Parker hoodie and search. Like this manner, for the merchandise which you can use search rights, there is the mark, and also if you tap this icon, you can conduct a similar merchandise search. Next is the Yahoo Japan auction site example. In this auction site, when you register merchandise, the Vald is utilized to make assumption for the possible merchandise information. For example, let's take a picture of the Apple Watch to list it. So the taken photo you had can be utilized. So there is an assumption for the product name by utilizing the photo. So just taking a picture, the merchandise title and the brand name can be shown as an assumption. So saving a lot of incumbent process for the user. Next is the National Library, the website, Japan Search. So you can conduct an article based on the keyword, and there is a button for the similar image search. And if you click the button, you can conduct a search on a journal or article. For example, the result of the Mount Fuji search result, if you click one and execute a search, then you can get the search very similar to the image as the article search. Lastly, I'd like to cover the Hack Day, the winner of the Vald code pairs. And they are using a code word, and the source code will be utilized, and there is a similar search of the source code to be performed. In this manner, vector search can be utilized for object data other than images and videos. From now on, I'd like to explain how to install and demonstrate Vald. Vald can be deployed in two ways. One is to utilize the Helm command. The other is to utilize Vald Helm operator. For the Helm-based method, it can be deployed in a few steps. All cluster operations are done with the Helm command. Later, I'd like to show you a demonstration taking a same approach. And the method using a Vald Helm operator, it utilizes the customer resource definition feature of Kubernetes. So the Vald Helm operator manages the Vald cluster to achieve the ideal state by relying on the predetermined CRD. So all changes to the cluster settings can be made with the Kubernetes CI, kubecti command. This is the recommended method for using Vald clusters in a production environment. Next, let me show you steps of the deployment before showing the deploying demonstration. There are 4 major steps. Step 1 and Step 2 are preliminary preparation phase. In Step 1, there is the preparation for the Kubernetes cluster to be deployed. In Step 2, add the Vald chart to Helm repo. So in Step 3, by user, there will be a parameter for the deployment, and there will be a creation of that Valdian part. And last, utilize the film install command to deploy the Vald cluster. Now, I'd like to move on to the Vald cluster deploy and the child-based, similar image-based search using a Chive. And GitHub is the place you can do it if you have more interest.
That's also available on the GitHub. So
deploy this.
First step is after taking the Kubernetes cluster information, run the Helm install command. And once that's success, you can see that the pod was launched. And at that time, config map, service, deploy, Kubernetes resources are automatically launched as well. And for Vald cluster, each components are codependent. So once those components once the components started up, and the codependent components start up as well. This time, Vald LB gateways and manager index and gateways, and those launched as well in that order. And from now onward, using the Vald cluster, we would like to show you the Chive demo. Chive demo we can run with the Jupyter notebooks and by clicking. First, regarding a pre-process to the vector insert. In the pre-process, demo package installation is done, and after that, install about Python client. Then, let us read the data and then vectorize this list test. And once the vectorization is done, you can see that these rows are attained. Now let's insert them into Vald cluster. And at that time, when making the insert, you set the host and create a gRPC connection. First, create channel. Then, using the channel, create the stub necessary to make the insert. ID, test, those vectors are inserted, and once it's success, you get this kind of output. In this demo, we are inserting 10,000 vectors. And once those are done, you see that this bar chart would show 100% complete. This is a pre-process and the demonstration for the insert. Next, I would like to explain about the search phase. For Vald search, there are two types. One is for query, another is using query, search by ID. For search, using the query called test, search for that and get the top 10 vectors, and let us do the search. So once we run the search, you see that the vectors that are close to the query's search, the top 10. Then next, let us conduct search by ID. And this time, using the ID as a test, let us do the search by ID. And the result is same as the one before. You can see that the top 10 outcomes were attained that are similar to the result before. Next, vector update and vector deletion. And for updating, and vectors ID that we like to update, and also set the new vector ID. At this time, we are making a change from ID from Japanese test to English test, TEST. Once that's a success, we should get that kind of output. And whether this was in fact updated, let us do the search by ID. Then once we run that search, you can see that the different results got returned. As you can see, once updating, you can get a different search result by updating vectors. And in the end, about the deletion of vector data. First, we specify the ID to send a removal request. Once the removal is possible, all the agent that holds the indexing, all the corresponding vectors gets deleted. Let us do the search to make sure that this was in fact removed. Here, using the method called exists to do the verification, you can see that the vector is not found as output shows, and you could see that in fact they were removed. Lastly, as advanced, we would like to do near ANN search to do the word analogies. This using the vector expression of words to do addition and deletions to find the words that are similar in meaning. For example, king minus male plus female equals queen. So that type of vector expression gets returned. So you can see that the wording that are close to the queens get returned. Similarly, from PSX, we can withdraw Sony, then add Nintendo. Let's see what kind of results we get. And this is the result that we got. So this concludes the text search using a Chive dataset. Thank you. Lastly, the cleanup of Vald cluster. A Vald cluster that was deployed in Helm command, we can use Helm uninstall command to remove the cluster. Once the uninstall command was success, as you can see, all the components within the Vald cluster get deleted, and also resource on the Kubernetes get deleted as well. That's all for the demo. Now I'd like to share the most up-to-date roadmap for Vald. In 2002, we plan to add 2 additional core algorithms. One is a face, which we got a lot of requests, and also QBG using the quantization graphs on the public beta. And for 2023, we are planning to offer continuous benchmark tools and the request mirroring functions and network policy. So now the summary. Today's presentation started with an overview of vector search and introduced vector search engine. We also introduced in details of outlines, features of Vald that we are developing, and gave a demonstration of vector search. And we hope that this session was helpful for you to gain a deeper understanding about the vector search. This is a product that is developed in OSS. I hope you can give it a try, and we welcome your feedback and your advices, public documents, GitHubs, and Slacks. If you could please check out the Vald, that would be great. And we are very much waiting for your contribution as well. And thank you very much.
Mr. Kato and Mr. Yukawa, thank you very much. From now on, we'd like to invite a questioner, interviewer, to focus on the essence of the presentation with a deep dive. And wherever possible, we'd like to also entertain any questions from the audience. Bottom right, you can see a question mark. You can submit your question too. Interviewer is Mr. Harumichi Yokoyama from LINE. Mr. Yokoyama, could you introduce yourself briefly? Yes. At LINE, I'm covering a machine learning area as a machine learning engineer. Nice to meet you. In the recommended engine development and operation are the main area. Thank you. Thank you very much. Thank you. So, from now on, Mr. Yokoyama, have you had any points you have particularly find it interesting? The presentation was very comprehensive and it's easy and straightforward to understand. Thank you. In development process, there will be technical challenges. So could you share some technical challenges during the development phase? So if I may make answer or respond. Yukawa-san, could you show us the architecture slide? Yes. So there are prerequisites. In-memory system is a Vald. So all the vector data will be actually deployed and available on the memory. And Kubernetes itself is a stateful, but many users are using it actually stateless. So in the Vault, the agent vector data will be gone. Its bot is dying. So agent and Kubernetes node, even it's stopped, it's possible to search cluster result. All the search results should be searchable. So these are very difficult areas, and we got a breakthrough. We mentioned earlier about the importance of the indexing resource-based algorithm, and also the number of replicas and users traffic will be adjusted by SL. So when there is a failure of Kubernetes, the stability was much improved, even if there is the instability. So that is a very difficult step in development. You mentioned the challenge in actual operation. Have you had such a phenomenon in operation? Yeah, true. Originally at Yahoo Japan, NGT, that's the NGT was on the server, was available, but we utilized Envoy to perform clustering. That's before Vald. But we deepened the knowledge from there, and we found that this particular solution, so it's based on our experiences, and this particular solution was born based on such experiences. Oh, thank you. And there is one more question.
In the use case that you showed, I understand that this is used at various service applications, but what you have developed, and in order for many users to use it in different use cases, are there any things that the user side need to be aware of in terms of using it in the best way possible? The difficulty of using Vald for multiple services is technology aspect and also the scope. This users having the vector search knowledge is still very limited at the moment. For us, we were hoping that the Vald gets used for scientific purposes. We started by approaching those who were knowledgeable in vector search. Then now, as a managed service for the internal company usage, we are developing more and more use cases. We would like to get to this a sort of vector embedding. Vector construction is on the user side responsibility. Going forward, foundation type models or more general purpose models, when the vector usage becomes more easier to handle, then I hope we can reach out to more users. Sure, developing embedding and the search requires a different technology, but I do understand that there's a synergy and you need to have both knowledge, otherwise you won't be able to have a quality final product. So I understand you made a very good point.
So we got a question from the audience, which we'd like to share with you. The Vault, how the Vault was named, and why you decided to make it available on open source, because usually you use it for internal purposes. Why you put it on OSS? So for the name of Vault, well, there were many ideas within the team members. In the past, there was a NGTD cluster name, NGTC or NGT cluster. There was some other proposals. However, to indicate that you can handle a lot of vector data and the vector search, we had a forest of the vector. That's in Japanese. Vald is actually based in the German, indicating forest. So that is how the Vald was born. And to make it available in open source, originally at Yahoo Japan repository, there were many software tried to be offered open face. And there were many use cases that we find it valuable for the feedback from the external as well as the internal engineers. So we're driving such cycle of the feedback. It will be beneficial. So we decided to put it in open source format. OC. I thank you very much.
By making Vald open source, are you getting more issue reports and you're able to, and I'm sure you need to spend more additional resources for fixing. Sure, R&D cost is necessary here. This is software free of charge, but we are allocating our own team members' resources to make necessary fixing from the report from the community. But you know, those fixes that's probably necessary for our internal use as well. So we believe that there is a purpose. There's a rationale for us to make that resource available to do the fixing from the request of open source community.
Another question. So ANN primary softwares, many of them are already available versus other products. How have you been differentiating from other offers at Vald? This is the Mirvas and Weaviate and Quadrant. Filtering and hybrid search had been incorporated in their features, but Vald intentionally had not incorporated them because of the ANN algorithm. We shouldn't incorporate anything more because it will be reduce the speed, and software filtering will be deteriorating the the aspects. So the vector search will be utilized. So without such incorporation, and the vector data will be utilized by user to do some other operation. It's up to the user to decide how to do it, because we understand the benefits all in one service, but intentionally simple and high speed is a major feature for the Vald.
I understand. Thank you very much. Other question that we are getting here is, with the increase in data, you won't be able to put everything on memory sometimes. Of course, calculation done, computation done in a distributed manner, that's a way to get over the difficulties. But do you have challenges in just doing that? Or do you have any expertise that you gained? Within December, we are planning to make this additional feature, quantization. Once it's a quantized pulse is made, the volume size it shrinks. Therefore, our memory usage it becomes less demanding. And for Vault, we are going to offer next year continuous benchmarking. With that, Vault will be able to conduct 365 benchmarking. We will always be able to continuously get the profiling. Then we know that what are the areas to watch out for the memory shortage. So as far as resource allocation, we are quite aware that those issues need to be resolved ASAP.
So on this page, I have some question or clarification. Top K, large top K efficient search will be planned. What types of the factor have made you to think in that way? Yuka-san, there was a search DN information you showed us earlier. Could you show it again? Where? Yes, this is the one. It's on this graph, top K2. There is a number of units agent, and there is the return of the search result number 3. But in the top K, user is significantly high, 10,000 or more, and 10,000 K will be processed in number 4 step. In the LB algorithm, not all of them will not be processed, but the processing volume will be up. So the time will suffer for the processing. In order to reduce such time required at second step number 2, the team is studying to possible reduction of the K. But the agent 1 to N, there is a replica available. So you don't have to search 2 individually if there are 2 because of the replica. So that's a discussion we have within the team members. Then if there are 1,000 top K, then 500, the reduced number can be run, so that the result we get will be aggregated as a whole. So that's a plan we have. Thank you.